Section 7.5, Exponential and Logarithmic Equations. By the end of today's lesson, students are going to be able to solve exponential and logarithmic equations. We will first look at solving exponential equations that we can make have a common base. So our first example is 27 to the 3x power equals 81. So looking at 27 and 81, we need to make them have the same base. So I know 27 is 3 to the third power. And then I know 81 is 3 to the fourth power. So I have to first multiply my two exponents. So that's going to give me 3 to the 9x power equals 3 to the fourth. When the bases are the same, they cancel out. And then to solve for x, you are going to divide by 9. And so your answer equals 4/9. Our second example is going to be exponential equations that have different bases. So I would try to do the exact same thing that we did in example 1. I would look at my 5 and I would look at 130 and I would try to make them have the same base. But there's no way 5 to any power would ever give me 130. So instead we just have to change it to log form. So this is my base, exponent, number. So we write the log base 5 of 130 equals 2x. Now over here on the left hand side, if you were to ignore this minus 2x, this looks like the change of base formula. So we do the log of 130 divided by the log of 5 equals 2x. And then eventually we're going to get rid of that 2 by dividing by 2. So you would pick up your calculator and you would do log 130, close your parentheses, divided by the log of 5, close your parentheses. And you get this big decimal. So I'm going to write it down just so you could check your work if you were working along with me. And the reason is you don't want to round ever, okay? So I'm going to keep it in my calculator. To get rid of the 2 that's out in front, I'm going to divide by 2. Again, just don't clear your calculator, just click divide by 2. And I get, for this problem, that x equals 1.512. Let's give 3 decimal places so we can be more exact. Our last two examples were exponential functions. Now we're going to switch over to logarithmic equations. So I gave you the log of 3 minus 2x equals -1. So always to get rid of your log that's out in front, you have to change it back to Bend form. So when the base isn't written, it's an invisible 10. So you do 10 to the negative first power equals 3 minus 2x. 10 to the negative first power is the same thing as 1/10. Then to move our 3 to the other side, we need to subtract 3. I have to multiply this by 10 over 10, so that way I can combine my like terms. So that would be -30 plus 1, which is going to give me -29 over 10. Then to get rid of our -2x, we would divide by -2. But since there's already a fraction on the other side, I'm going to multiply by -1/2 because it does the exact same thing. So you do -1 times -29 and it makes it +29. 2 times 10 gives me 20. So your answer is 29/20. In our last example, we are going to use all of our properties from section 7.4 to combine and make it one logarithm before we can solve. So, since we have the log of 6 minus the log of 3x, you know minus means that we can rewrite it as division. So we put 6 on the top, 3x on the bottom. If it was a plus sign, you would have rewritten it as multiplication. And remember, if there was a number out in front, you would have made it the exponent first before you multiplied or you divided. Now we need to change it to Bend form. So this is my base, my number, and my exponent. Again, there's no base there, so it's a 10. Okay, 10 to the negative second power is the same thing as 1 over 100. And then let's just cross multiply since we have two fractions that are equal to each other. So 3x times 1 is 3x. 100 times 6 gives me 600. And then to get rid of the 3, you divide both sides by 3 and you get x equals 200 for this problem.